Hi everyone, so now we're back in the last video for today. So in this part, I will talk about multi-core and multi-threading. In the recent years, so most of the laptops or PCs has used a multi-core CPUs to run its operating system. So basically, you can see or check whether your PCs has multi-threading capabilities by pressing Ctrl Alt Delete, go to the task manager and then select performance tab and go to the CPU section. So in this machine, the machine use Intel i7 which has 4 cores. So we know now that this is a multi-core CPU, and how we will know whether this machine support multi-threading or not. So basically it can be seen in the logical processes. If the logical processes, the number of logical processes is higher than the number of cores, it means that the CPU support multi-threading. So in this example, you can see that 8 logical processors are with 4 multi-core CPU. So in this case, it means that one core will support 2 threads of simultaneous execution. Okay, so what's the difference between logical processes and also cores? So cores has its own ALU, it has its own level 1 and level 2 cache, while for logical processes, so it only has registers and it will share the ALU and level 1 and level 2 cache on each core. Alright. So now let us move to how performance is measured for multi-threading in a multi-core or multi-processor system. So to measure performance of multi-threading in a multi-core system, so we will use the performance measurement parameter, which is speed up. So what is speed up? Speed up is what are the potential performance, okay, that we can benefit from the multiprocessing capabilities. All right. So how do we measure speed up? We measure speed up by finding the time to execute in single processor and divide it with time to execute in multiprocessor. So for example, if we have a single processor, so say for example, if we have single processor, so the time taken to execute one instruction is 1 second. Okay, so what is the time to execute in multi-processor? So for example, if you have 2 processor, so 1 second divided by 2, which is 0.5. So this is the time to execute a single instruction in multiprocessor, which is 0.5 second. So to calculate the speed up, so we just divide 1 with 0.5, so we'll get the relative speed up, which is 2, which means to execute in a multiprocessor system, so you can double the performance. Double, it will speed up by 2 times. Okay, it will speed up the process by 2 times if you have a multi-processing system. Okay, in this case, when you have 2 cores. Okay, so if you understand it, it can be seen that um, by having a multi-threading, okay, so when you have a multi-core, so you can run and double up the efficiency of the processing by 2 times. Okay. However, we need to understand that, okay, this is only in an ideal situation, okay, but in reality, this is not the case, okay. So in reality, we need to understand that a program, a program may consist of serial. When you have a program, it may consist of serial and parallel code. Okay, so for example, what is the difference? Meaning when you write a program, okay, So there is a part of the program which is can be only processed in a serial manner or sequential manner. What it means, like if you have 10 instructions, you process, you execute the first instruction followed by two, second, third, fourth, and um, so on and so forth. Okay, so this is like when you use array, okay, when you use a linked list, okay. So basically, if you have a serial code in your program, okay, you cannot use parallelism. Okay, you cannot employ multi-threading or parallelism for running the code. Okay, so basically, because of that, it will having a serial code in an application or program will slow down the performance. Okay, so this is what Amdahl's law all about. So Amdahl's law um, assumes that if a program have some part of the program has a fraction or percentage of serial code in the program, so basically it will reduce the performance or speed up of the program execution. So in Amdahl's law, rather than using this formula, which is time to speed up is equal to time to execute a single process divide by time to execute the program in multi-process. So Amdahl's law assume that if you want to calculate the time to execute a program in multiprocessor, you have to add the time taken to execute a serial code plus the time for parallel code. Okay, because we know that in in serial code you cannot employ parallelism, so you cannot use multi-threading, cannot two threads running simultaneously because the instruction need to be executed sequentially. So in order for us to calculate, okay, in order for us to calculate for speed up, if you have a serial code in your program, so first we need to identify what are the percentage of the parallel code. So say for example in a program, okay, so for example in a program, if you have part 10% of your program is serial and 90% of your program is parallel. Okay, so F is equal to percent of the parallel code, which means 90%. Okay, 90%. So how do we calculate speed up? So actually the calculation is the same, which is time to execute single process, which time to execute single program in a single processor, which is 1 second, divided by time to execute the program in multi-processor. But in calculating time to execute the program in multi-processor, so we need to use this formula, okay, or here. So now 1 minus f is the time taken to execute the serial code, which is 1 minus, so the percentage, the percentage. Okay, so 1 minus 0.9. So where do we get 0.9? We get 0.9 from here. Okay, from here. The percentage of the parallel code. Okay, and then plus f, which is 0.9 divided by the number of processors. So in this case, I use the same number, which is dual. If your CPU has dual core, which is 2. Okay, so eventually we will get 0.1 plus 0.45. Okay, which is 0.55. So the speed up, relative speed up is 1 divided by 0.55. So we get the final relative speed up as 1.8. So you see now the speed up has been reduced. Previously, is 2 times faster. Now it's only 1.8 times faster in executing the multi-threads on the multi-core CPUs. All right. So I hope you understand. So with that explanation, so you can see or you can understand the diagram. So here, this one is ideal. In ideal situation where no serial code. Okay. So you can see that if you have two processors, so you get here 2 times speed. Okay, 2 times faster. But when the fraction of serial code is 10%, so you see now I don't know whether you can see it here. So here, so it becomes 1.8 times. Okay, relative speed up, meaning now it's not as faster as before when you have no serial code in the program. Okay, so I hope you can understand that. So with more number of processors, so the relative speed up, the differences in the relative speed up will be coming higher. So you can see that when you have even 10% of serial code, so it will reduce the performance from 8 times faster to 4 times faster only. Okay, so basically the number of serial code in a program will affect the performance of program execution in a multi-core system. Okay, so that's why it shows the importance of multi-threading, meaning when there is more instructions could be run in parallel, so the performance of the program execution will improve. Okay, so in this diagram, what this diagram shows, okay, is sometimes a program sometimes incurs overhead, which is the result of communication or task distribution between multi-processors or from one processor to another or for synchronization. So because of that, even though when we apply multi-threading and multi-core and multi-threading, so at some point of time the performance will be stagnant or degrade because of due to the overhead. Okay, due to the overhead, because when you have multi-processors, so you need to have a communication between threads, okay, communication, and then you must employ some synchronization between multi-processors, okay. So at some point it will introduce overhead and the performance will decline, okay. All right. So the more number of processor, okay, the more overhead that it will introduce. So in this example, so you can see that the performance is quite okay up until 4 processor, but 4 or 5 processor after that, the performance or the relative speed up degrades due to the overhead. Okay, but in actual, there's so many research that has been done to improve the performance. That's why it is said that for multi-threading, yeah, is good to be used in database management system or database application where the number of CPUs will improve the performance of the such system. Okay, so that's all for today. So I hope you guys can understand our lesson, which is threads. So that's all, and I hope I can see you next week with another topic. Assalamualaikum and good day.